Hi, this is Dean from SYX6660. This is a video explaining how to set up the SYX6660 range of controllers using a web browser connection. So the first thing we need to do is establish a IP connection for our web browser to use so we can talk to the controller. So we do this by opening up network settings on the laptop, whichever device you're going to be using. So to do that, just click on your network connection or network status icon and choose network and internet settings, and we're going to set up our Ethernet port. So we need to select change adapter options, and we open up our Ethernet port and we choose properties, and we open up Internet Protocol version 4, double click on that, and we specify a fixed IP address. Now the controller comes from factory with a default IP address of 192.168.1.99, so we have to be anything other than 99 between the range of 1 and 255. So 255 is excluded, but we can go to 254 or 1 or 99 other than 99, shall I say. So I'm going to choose 100, and the IP address subnet mask is 255.255.255. We don't need to put a default gateway in for this exercise, and leave the DNS server just ticked as is. Say OK, and now we can open up a web browser, close down those windows. You can use any web browser. I tend to use Safari or Chrome. I'm going to go for Chrome in this particular case, but I'll show you the other application working at the moment. I'm going to type in the IP address of 192.168.1.99. You can see I've used this before, it's in my history, and I'm going to hit OK, and now I can access the controller. We can choose to use the default web browser, which is the one you can see on the screen now, or we can set the controller up using a different web browser connection by entering in the same IP address 192.168.1.99, and this time put /mo/, and we end up with the modified user interface, which is designed for the touchscreen. Some people prefer it because it's a little bit more user friendly, a little bit more attractive to look at. There's no difference between the two web browsers, but we'll use the MO one for now. You can make it slightly bigger. If you hold the control key down on your keyboard and pulse the plus key, you can make the screen slightly larger, or if you hit the minus key, you can make it slightly smaller. I'll just make it slightly bigger for the benefit of the video. Okay, so we now have access to the controller, and we can log in using user level 2. We need user level 2 to gain access to the configuration parameters which allow us to configure the application of the controller. So I'm going to choose user 2, and the passcode is 0112, and then click set. Okay, so now we've got access to the controller. So you can see that there are 5 menus on the screen. Each of these bars are elements that you can click on to go into, and all we do is we select, first of all, the functionality of the controller. We're going to set up how we want this controller to work. So I'm going to assume that we've got a typical optimizer compensator circuit where we've got 2 boilers, a variable temperature circuit, and we've got some hot water that I need to have boiler linked to the controller. So we want to have the boiler to operate when there is a demand for hot water. So if you understand the application of the controller, the hot water signal can be connected to the auxiliary input of the SYX controller, and when there is a hot water demand, we monitor the control circuit on a volt-free contact. So when we have a demand to heat the hot water tank, we can monitor this volt-free contact, and we can then run the boiler plant to service the hot water needs. Okay, so that's what we're going to set up first of all. So we click on overrides, and we drop down to the menu where we see the option called setup. So the first option for setup is, do we want to have hot water extension? So this means that the digital input on which is used for the day extension timer for the heating system, do we want that also to bring on the hot water system? If we want to have it so that the heating and the hot water are brought on when that button is pressed, then we leave it enabled. If we want to disable it, we can select disabled. The next option we choose is the auxiliary switch option, and as I just discussed, we want that to be used for hot water demand control. Frost mode is a holiday switch. The other options here is hot water demand, which is the one we're going to select. Summer mode, which would disable the heating but leave the hot water enabled during the summer months. And the other option here is underfloor heating demand. This is where the SYX controller is enabling underfloor heating circuits, and we wait for a demand signal for heat from the underfloor heating manifolds. Again, all of these circuits are expecting a volt-free contact coming into the terminals of pin number 10, which I believe are terminals 29 and 30. Okay, so we're going to select hot water demand. Okay, and those are the two options which are in the override menu. So I'm going to go back now onto system, and now I'm going to choose heating. So I'm going to tab down again, find the setup mode, and we can see that the default operation for the heating system is optimizer compensator. The options in there are night setback. This would be something I would select for something like a care home or something with 24-hour occupancy, something like a hotel or something where there is a constant heat demand, something like a fire station maybe, where we just throttle the heating by a reduced level throughout the nighttime period. Timed on off, obviously that's exactly as it sounds. This is where there is no occupancy at all, out of hours, and we can drop the system back to a timed frost protection level. This is slightly different to an optimizer compensator, where out of hours we also turn the heating off to frost level, but there is no optimum start with the timed on off. So this is for somewhere where there's a small facility. They don't really want the features of an optimizer. It could become a little bit disruptive for them if plant is starting up out of hours in order to heat the building up. But obviously from an energy performance point of view, an optimizer is always preferred rather than having a fixed time start where you could be overheating a building or even underheating it from a comfort point of view. Optimizer only, which is the bottom option on this particular page, this allows us to drive the pump output from an optimizer start perspective. There is no other temperature control functions with this. It's purely an optimized start function. The output will remain on for the remainder of the day, and it will optimum off. There is no additional boiler control. The hot water menu still remains active, but it doesn't sequence the boilers, and it doesn't provide any variable temperature control. The next option at the bottom of the list is the optimized Y plan. This is for large domestic applications where it will conform to the Y plan, which is the typical domestic arrangement, but this is an enhanced feature of the Y plan in that we optimize the heating circuit. Okay, so we're going to leave this set at optimizer compensator, and we're going to look at the next option, VT set point. VT set point says self-adaptive. This is where we take some what we call room influence from the space temperature sensor, which is used for the optimization of the system, and we have the ability to adjust the heating curve or the heating set point by an amount proportional to the difference between the room temperature set point and the current room temperature. So if the room set point was say 21 degrees and the current room temperature was 19 degrees, we are technically under the set point. So what we can do is we can use the VT set point adaptation to increase the current calculated flow temperature to close the gap between the current room temperature and the current room set point. And there is an adjustable ratio in the controller in the heating menu called room influence, where the default for that parameter would be 3 degrees. For every 1 degree you're below set point, you would increase the flow temperature by 3 degrees. Alternatively, if you were above set point, you can also reduce the flow set point as well, so that you have this live influence over the radiator temperature to try and affect some comfort and some better energy performance. Okay, so if you don't want room influence, you just select non-adaptive. If there are no room sensors available, then it will become automatically inactive. Okay, optimum off. Throughout the day, the controller will be monitoring the current room temperature, and it calculates the warming downtime or the cooling downtime of the building. So if you were to turn the heating off in the building, how quickly would that heat in the room decline over time? And so the controller monitors that, and it can make a prediction of when to turn the heating off prior to the programmed end of occupancy. So if there is a little bit of surplus heat, we can utilize that heat in order to save some energy by running the plant to the end of occupancy time. We can just end the occupancy, the heating of the building early to utilize the retained heat, and we want the space temperature to be maintained until the end of occupancy without actually putting any heat into the space. So optimum off, it is subjective to having a good location for your room sensor. You don't particularly want this in a particularly warm area of the building, where if it did achieve some additional capacity and you turn the heating off, you will of course be turning the heating off for the rest of the building. So it is again subjective to the correct placement of the room sensor in a representative location. If it becomes, it's always recommended to leave optimum off active, but if you do need to disable it, this is where you can do it. Hot water priority gives an opportunity if your heating plant is a little bit undersized, or there's been some expansion on the heating system which has left it undersized, the hot water may become slightly underheated during peak demand conditions for heat in the winter months. So what you can do is you can select how you want to disable the heating system. So you can disable the pump, or you can close the valve of the heating system in order to afford greater flow of primary water to the hot water tank, should obviously the hot water be boiler linked in this particular case. Flow economy mode, this is a feature of the controller that has a energy saving benefit. This is to do with the controller identifying that the flow set point of the radiators on a particularly mild day with a warm room temperature, which is above or very close to set point, the actual heat input into the system will be very low. So if you have a set point which is calculated for the radiators, which is within 3 to 5 degrees of the calculated flow set point, then the flow economy mode will become active and it will disable the heating. Again, this can cause some conflicts in some buildings where you've got very, very efficient thermal mass and the building heat retention is very good and you need very little energy to heat the building up. On a mild day you could in fact have a situation where the heating would be disabled because your calculated flow set point is very, very close to the room temperature. So flow eco mode will kick in. It will also kick out again should the parameters change, but equally it will come up with economy mode on the system, and that will be the reason why. Again, if it causes a problem or you're a bit unsure, you can always disable it by clicking on the inactive function. Optimizer adaptation is the facility for the optimizer to learn the warming up rate and the cooling down rate of the building. There are some features in the controller where we'll touch on later about the optimizer warming up rate. If the building takes an extremely long time to warm up, then the warming up rate can become a very low number. If that number goes below 0.5, or effectively 0.5 degrees C per hour warming up time, that's a very long time. That would be 2 hours of heating for every degree C of heating for the building. So what we have the ability here is to identify what the problem is for the long warm-up time, but during that time where there is a situation where the warming up is taking a very long time and we want to understand why, it might be advantageous to disable the optimizer adaptation, and we hold it as a fixed rate until we identify what the problem is, and we can disable the adaptation by clicking on disabled on this screen. Okay, so that's the heating menu now set up with its main functions. We can now go back on system and choose the next option, which is hot water. Again, we tab down to the setup menu, and this is where we can choose whether the heating for the hot water is from an independent source, such as a gas-fired water heater, or we need it boiler linked. So we do need boiler linked on this application, so we're going to select boiler linked, and that concludes that menu. So quite straightforward. We now click on system, and we click on boilers, and we tab down to the setup menu. This is where we can choose the number of boilers, and we click on 2. We can now, because we've now got 2 boilers, we can select, well, the option to rotate the boilers becomes possible. It may be the case that you may have 2 different styles of boilers, where one is a condensing boiler and one maybe isn't, because of, I don't know, upgrade plans or upgrade potential to the system. If you do not wish to rotate the boilers on a weekly basis, you can leave that as disabled, but if you do, we can set them up as enabled. There's a time schedule which is pre-programmed into the system, which is set to rotate at midday on a Sunday. You can set up additional times for that, but the default is fine for now. We just go back onto system and choose boilers. There were some other options there, which was Boiler Pro used. Now the BPRO is a sequence module which utilizes the 0 to 10 volt signal. If we use a BPRO, then we need to be sensitive about how the voltage levels work on the 0 to 10 volt ramp, because the BPRO becomes active above a certain voltage range. So we need to make sure that we are able to drop below that voltage range and turn off the Boiler Pro. So when we select no, then we could use that 0 to 10 volt signal for other purposes. The final option is if we have elected to use a boiler flow sensor. Now some applications may be replacing existing equipment, such as like a DC1100, where that particular product did not necessarily have to have a boiler flow sensor. If you don't have one, you need to select this to be no. In our application we do, because that's the most efficient way of modulating the boiler output to match the loads. Okay. We now click on system and we go to connections. If we're going to be utilizing the 0 to 10 volt output, we can choose what that output is used for. In this default condition, it's the VT valve. If we wanted to use it for boiler demand or a Boiler Pro, we would select boiler percentage. If we wanted to have the boilers driven from a 0 to 10 volt signal for a set point, then what we could do is select boiler set point, and then we can choose values, and we can set up the set point low and the corresponding voltage that we require, and we can do that from the set point high and the max voltage that the boiler would accept as well. Okay, so we're not going to be using the 0 to 10 volt output, so I'll just leave that set as VT valve. Pump changeover modules is the final option. If you're using our pump changeover modules where you've got 2 pump heads being changed over on fault or for flow failure, that module will coordinate what the lead pump is, and what we need to do is, given certain applications of the controller in certain times of the year, it may be that the pump output is always energized from the SYX controller. So for example, if it was a day-night setback operation, the pump would always be in operation, so we would have to forcibly turn the pump off for a short period of time in order for the pump changeover module to do its weekly rotation. So if we are using pump changeover modules, we can effectively turn off those pumps to ensure that they would turn off at one point, either daily or either weekly. And that's what that does. You don't need to change the times of those. It just turns the pumps off for something like 15 seconds to allow the pump changeover modules to rotate the pumps. Okay, and that concludes the major setup pages of the SYX controller. Okay, so having concluded the setup of the SYX using the main menu of the MO browser, which we discussed the two different versions in the first part of the video, I'm now going to quickly show the other browser functionality. You can see here it's coming quite large. That's because I zoomed in on the previous browser image. So I'm just going to hold the control key and press the minus key to zoom it back into frame. Okay, we can choose the login function, user 2, and same passcode 0112, hit login. This is quite nice from a more of an engineering perspective. We can do a few extra things that we can't do on the MO browser, such as adjust the date and time. We can set the time zone and set the time and date should there be a slight bit of drift, or you may need to make some changes based upon maybe fit in a different country. We can look at the pins which are live on the controller. This is a lot better for commissioning. Saves you dropping in and around different menus to look at what the condition of the inputs and outputs are. So obviously here you can see all the sensors, you can see what the current condition of the outputs are, which is quite nice. So it helps you do some fault finding if there are some little debugging things to go through when you're doing the wiring. In terms of the overview, we get the same menu functions, and there's no real difference to this at all. This is quite nice for us to know as well if there is a concern or query. Since the product was introduced, there's been a number of software upgrades about where we've introduced some new features to the controller, so it's quite nice if you do need some support that you can have this information available. Okay, that's about it for the additional browser, but every other parameter is just the same as the previous video.